Hello friends, my name is Tushar and today I'm going to talk about string permutation problem. So you're given an input string AABC, so this is the output we are looking for. Notice how the output is in the lexicographically sorted order. So there are a couple of techniques to solve this problem. The technique we are going to discuss today outputs the result in lexicographically sorted order, and it also handles the case where there are duplicate characters in the input. The more popular technique, which is based on rotation, doesn't do either of them. So why there are 12 output for AABC? So AABC is 4 character long, so 4 factorial divided by, since there are 2 duplications of A, so 2 factorial. So this is 4 into 3 into 2 by 2, which is 12. If the input looked something like A, B, 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 C, in this case the total number of output would be 6 factorial divided by 2 factorial into 3 factorial, because there are 2 count of A and 3 count of B, and this number would be 60. So next, let's see how we're going to solve this problem. For input string AABC, first we create count array. So there are 2 counts of A, 1 count of B and 1 count of C, and notice how ABC is sorted. Then we're going to take a result array which is of same size as my input array, so in this case 4. So the idea behind the algorithm is to go from left to right and look for the first available character. A character is available when its count is greater than 0. Then we put that character into its corresponding position in the result array by looking at the depth of the recursion. So if we are third level in the recursion, then we're going to put at the third position in the result array. And then we're going to go into the recursion again after decrementing the count, because we use this character. And then when we come back from the recursion, we restore the count back to its original value, and then go into look for the next available character on the right side of this particular character, and keep repeating this process. So next, let's do the dry run of this entire logic on this input here. Starting from left, we are looking for a first character whose count is greater than 0. So that character is A. So first thing we do is we go to its corresponding position in the result array. Here we are at the 0th depth of the recursion, so we go to the 0th position in the result array and add A there. So this becomes A. Then we are going to go into the recursion from here. So when we go into the recursion, we are going to decrement this count because we used one instance of A. So this really becomes now A, B, C, 1, 1, 1. Also, I'm going to note that I went into the recursion from this character A. So when we come back from the recursion, we can continue from A. So here again, going from left, I'm looking for a first character whose count is greater than 0. So that's again A. So first we go into this corresponding depth and corresponding position in the result array as per the depth of the recursion and add A here. So A here. And then from here, we are going to go into the recursion again with A, B, C, and this time the count becomes 0 because last time it was 1, 1 and 1. So starting from left, we are again looking for the first character whose count is greater than 0, and this time it's B. So first we go to the 2 and add B here because this is the second depth of the recursion, and then we are going to go again into the recursion from here. So this will be A, B, C, and this is 0, 0 and 1 because we used one instance of B. And now we search for character whose count is greater than 0, and that's C. So first we go here and add C, and then go again into the recursion. So A, B, C and 0, 0, 0. When the count is 0, 0, 0, it means that this array must be full, and then we're going to just output the contents of this array. So this outputs A, B, C. Then we're going to go back into the recursion. So from here we end up here, and so last time we were in recursion, we were at C, so there is nothing to do after C. So we go back again into the recursion to this point, so to the second depth, and notice how we are restoring the count back to where we left. And so this last time we went into the recursion from this point. So next we are going to explore from here. We are going to look for the first character whose count is greater than 0, and that's C. So with C, this time we are going to go again into the recursion. So what I'm going to do is I'm going to first put C into the second position and go into the recursion. So this becomes A, B, C. And this time we used one instance of C, so our count looks something like this. We did not use B, but we used C. Then again, starting from left, we are looking for first character whose count is greater than 0, so that's B. So we go into the recursion from B, and in here we add B, and this looks something like A, B, C, 0, 0, 0. As soon as the count is 0, 0, 0, we just output whatever is in the result array. So that is A, C, B. Then we're going to go back here. So we came to this point from this B. So from here we are going to look for another character whose count is greater than 0. So there is none. So we go back into this point. So from here we have already reached the right end of the array. So there is no further to go to. So we come to this point here. So now here we're going to look for, after A, we're going to look for first character whose count is greater than 0. So that's B. So we come to this point, and from B we go again into the recursion. So let's do that. And before going to the recursion, I'm going to update the corresponding position in the result array to B. So we are at the depth 1. So in the result array, I set this value to be B. Then after we go into the recursion, the count array starts to look something like this. For B it's 0, for A is still 1, and for C it's still 1. Then we are going to again start from the left side and look for the first available character whose count is greater than 0. So that's A. So we go to this particular position and set this value to A, and then we go into the recursion from here. So this looks something like A, B, C, and now A is used, B is used, and 1. So again we start a new level of recursion. So when we start a new level of recursion, we again start looking for a first available character from the left side, so that's C. So then we're going to add C here, and then decrement the count of C, and then go again into the recursion. So as soon as the value is 0, 0, 0, we output the content of this result array. So my third output is A, B, A, C. Then we go back into the recursion. So I went into the recursion from here. We have already reached the right end of this array. So we go back to here, and from here I'm going to look for the first available character after A. So the first available character after A whose count is greater than 0 is C. So we are going to go here and have A, B, C. Count of A stays same. This becomes 0 and this becomes 0 because this time we used C. Also, I'm going to go into its corresponding depth in the result array and set this value to C. And now, since we started a new level of recursion, I'm going to again look for the first available character from the left, and then this time it's A. So I'm going to go to the corresponding position in the result array and set this value to A. And here, this becomes A, B, C, 0, 0, 0. As soon as this is 0, 0, 0, we're just going to output the result. So this is A, B, C, and A. So then we go back to the recursion. From after A, we are going to look for first character whose count is greater than 0. There is none. So again we go back into the recursion. So here we have reached the right end of the array. So we again go back here, and now we'll continue from after B. So after B, we are looking for first character whose count is greater than 0. So that's C. So from C, we are going to go into the recursion. So now so we used one count of C. So first we're going to make this guy C, because at this level we are using C. And then I'm going to set A, B, C. A is 1, B is 1, and C is 0. So again, starting from left, we're going to look for first character whose count is greater than 0. So that's A. So we're going to set this guy to be A. here A, B, B, C, and this is 0, 1, 0. And now the first character we encounter is B, so this value becomes B, and this value becomes A, B, C, 0, 0, 0. So now all characters or counts are 0, so we output this results. So this is A, C, A, B. Then we go back here. So here after B there is no character whose count is greater than 0, so then we go back to this level of recursion. And after A we look for a character whose count is greater than 0, so that's B. So now we are going to go into the recursion from B, and this will look something like A, 1, because now we are using B. So this value becomes B, B, 0, and C, 0. And now we are going to look for available character from the left again, so that will be A. So we're going to add A here, and this value becomes A, B, C, 0, 0, 0. So again all this count is 0, so we're going to output this result. So A, C, B, A. So these are the first 6 permutations of this ABC. So from here I go back here, and there is no available character here, so we go back here. After B there is no available character, so we come here. Here we have reached the right end of this ABC, so we come back here, and from here we are going to continue to the next character, which will be B. So let's do that. So I rearrange things a little here so that it fits in my whiteboard. So next let's do remaining part very quickly. So we went from A to B. So we go to B, we set this guy to be B, then decrement the count of B. So this really becomes A, B, C, and 2, 0, 1. And then we go from A. So first we set this value to A and decrement the count of A. So this really becomes A, B, C, 1, 0, 1. And then we again look for A. So this really becomes A. And this is A, B, C, 0, 0, 1. And then finally here it will become A, B, C, 0, 0, 0. And this value will become C. So we will output this as our 7th permutation, B, A, C. So then we go back into the recursion. So we come to this point. This has already reached the end of the array, so we come to this point. So we went into the recursion from this point. So next we're going to go from here, and this will become A, B, C, and 1, 0, 0, because we're going to go into the recursion from here. Last time we went from here, and we add C here, and then this will become A, B, C, 0, 0, 0, because we're going to add A here. And output this 8th permutation, which will be B, A, C, A. And then we go back here. There is no available character after this, so we come back here. This has already reached the right end, so we come back here. And then we're going to go into the recursion for the next available character, which is C. So from C, we are going to go back into the recursion. So leave the count of A as, so first we add C here and leave the count of A as is, BC. So 2, 0, 0. Look for the first available character from the left, so that's A. So make this A and go into the recursion again. So A, B, C. So this value is 1, 0, 0. And then look again from the left, and that value again will be A. So the next available, so with this guy becomes A, and this value becomes A, B, C, 0, 0, 0. So at this point we output this, which is our 9th permutation, B, C, A, A. And then we went into the recursion from here. There is nothing more available characters here, so we come back here. And after A there is no more available characters, so we come back here. After C there are no characters, so we go back to the top. And now we go from B to C, and repeat the same process. So this guy becomes C, and we go into the recursion from here. So A, B, C, and this is 2, 1, 0 because we used one instance of C. And again we look for first available character, so that will be A. So we go into the recursion from A, so this will become A, B, C, and this is 1, 1, 0. And now we have again look for the first available character from here, so that again will be A from the left. So again it will be A, B, C, 0, 1, 0. So this value is again A. And then we go back here and look for the first available character, so that's B. So this becomes B, and this is A, B, C, 0, 0, 0. So we output this as our 10th output, C, A, B. And then we go back into the recursion. So this has no more available character from here. So this has, here B is available, so we can go again into the recursion with A, B, C. Now the count of B will be 0, and corresponding position it will be B. So 1, so this will be used 0, and this is still available because now we went into the recursion from B. And this will again set this guy to be A because A is unused, so A, B, C, 0, 0, 0, which means we need to output this, C, A, B, A. And now we have one more permutation left. So we go back here, there is no available character here, so we come back here, there are no available characters here. So we come back here, there is, so last time we went into the recursion from A, so going next we have B left because B has count greater than 1, greater than 0. So we go into the recursion at B, so A, B, C, and 2, 0, 1, and this we set to B, and 2, 0, 0, and this we set to B. And from here we go again into the recursion with A count by decrementing count of A. So A, B, C, and 1, 0, 0, and then A, B, C, 0, 0, 0, and this value also becomes A. And this will be our final addition, C, B, A, A. And then we go back here to here, there is no more available character from here, so we go back here, there are no more available characters after A, so we come back here, go to this point of recursion, there are no more available characters after C, so we come to this highest top level of recursion, and after C there are no more characters. So these are our all our permutations for this string AABC. Again you can notice that they are all in the sorted order. First we take care of all A's, then B's, and then C's. So the time complexity for this algorithm is obviously factorial time because we can have total factorial permutations. And the space complexity, if we are not storing the output, will be same as the total number of characters in the input string because we are at max going 4 level deep into the recursion, which is the total length of the input. So next, let's look at the code for this algorithm.
Here is permute. It takes in an input character array. The characters in this array might not be sorted, and there could also be repetitions. So first we're going to take a map of character to integer, which is going to keep the count of every character, and then we're going to store those characters into the string array and their count in this count array in a sorted format. So if we had string ABC, our character array would, this character string array would have A, B, and C, and the count would be 1, 1, and 1. And then we're going to initialize this result to store all the intermediate results. And then we call this permute util, which will take this string array ABC, count 1, 1, 1, result array, which is of the same length as the original input array, and then the level, which is the depth of the recursion. So initially the level will be 0. And then we keep doing this recursive stuff. So if level is same as result.length, it's not. So we have I starting from 0 going till the string.length. So our I could be 0, 1, or 2. Initially I is 0. If count of I is 0, so count of I, which is this value, it's not 0. So we don't go into this if condition, and first thing we do is we add this we update the result array with A, and then we decrement the count, and then we go into the recursion. So what happens is from here we go into the recursion, and as you can see, we have decremented the count of a to 0 because we used a, and then we're going to look for the first available character. So if the count is 0, then we continue, and so basically I comes to I1. I0 is skipped because count of I is 0, so we come to I1, and then we're going to put b into the result and then go into the recursion again from the permute util. So we go into the third level of recursion and look for the first available character. So for I0 and I1 we will continue because count of a and b is both 0, so we reach c, and then we're going to put c into this result at the second level, at the second position, because we are at the second depth level, and then we're going to go again to the recursion, and this time our level will be same as result dot length. So we're going to just print this array. So we're going to print a, b, c, or the contents of this array, and then we're going to just return. So when we return, we go back from here to this point, and here our I is already reached 2, so there is nothing more for I to go to, so we go back to this level, and in here our I will move on to the next value of which is 2. So this is what happened. These two recursions are done, so they are orange now, while this is now current, and our I becomes 2. So when I becomes 2, so now we are going to so A is already there in the result array, and now we're going to put C into the result array. So C goes into the result array, and then we again call permute util and go into the recursion again. So this time we again look for the first available character, and the only available character this time is 1. So for count for I0 it continues, and we hit it for count 1. For count 1 this value is not 0, so we put this b into the final result and then call recursion again, and this time again the level becomes equal to the result dot length. So we print a, contents of the result array a, c, b, and now we're going to go back into the recursion. So as you can notice, while going back into the recursion, we are incrementing the count which we decremented before going into the recursion. So we go back here. When we come to this level, b we have already reached. We were already at b, and c is not useful because the count of c is 0. So we come back to this level, and in here I has already reached 2. So there is nothing much to do at. So we come back to the top level. So we'll come to the place. We'll come to the lowest level of the recursion and increment our I to 1. So when we increment our I to 1, so this is the 0th level of the recursion. So we're going to fill the 0th level, 0th index in the array. So this value becomes whatever is this at this position, which is b. And then we're going to decrement the count of b and then go again into the recursion. And we look for the first available character a. And again the same process happens, and we put a into this final result, and then again go into the recursion and look for the first available character, and that is c. And then we again go into the recursion and put c into the result array, and then at this point of time our length will again will be equal to result length, and we'll just print it, the contents of this array b, a, c. And then from here we go back to here, and this is already done. All the i's have been covered, so we come back to here and we look for the next available character after this, which is c1. So that's where we reach. So here we are going to put c into our result array because this is the first level of recursion, and then go back into the recursion, and this time the first available character will be a, so we put that into the result, and then we print b, b, c, a, and then we go back to the top, and this time I will become 2. And so first thing we put is c, and then go into the recursion again, and then we put a, and then go into the recursion again, and then we put b, and then go into the recursion again, and this is all done. So cab gets printed, and then we roll back into the recursion, so from here to here, and this is all done. So we come to this point, and our next recursion will start from b. So we put b into the final result, and then our next recursion will start from a, so a will go into the final result, and then this gets printed. And at this point of time we have printed all the permutations of this string, so we are pretty much done with the entire recursion. So I hope this helps you understand how this code is working. So this is all I have to talk about string permutation. The link to this code is in the description section of the video. Also, I have the code in Python for all the viewers who like Python. Please share this video, comment on this video, check out my Facebook page, and check out my GitHub link. Thanks again for watching this video.